This is another video on improper integrals, how to determine if they converge or diverge. So in this video we want to determine if the integral from 1 to infinity of 1 over x squared dx is a convergent or divergent integral. And if it converges, we want to determine what it converges to. So here our function is f of x equals 1 over x squared, and it's on the interval 1 to infinity. Let's graph this function on that interval and see what the integral represents. So here's the graph on the right side in the first quadrant of 1 over x squared. There's 1, and the shaded area represents the integral of 1 over x squared from 1 to infinity. If that area is finite, then the integral will show us what it equals to, and if it's infinite, then the function simply is not closing in on the x-axis fast enough to capture finite area. And the way we evaluate this improper integral is to first let t be any value, represent any value to the right of 1. And we know that the integral from 1 to t is finite. And we're going to take the limit as t goes to infinity. So this vertical line segment above t will keep moving to the right farther and farther. And if that limit exists, that's going to be the value to which the improper integral converges. So the improper integral from 1 to infinity, 1 over x squared, is equal to the limit as t approaches infinity of the integral from 1 to t, 1 over x squared dx, which is equal to a limit t approaches infinity. Antiderivative of 1 over x squared is negative 1 over x. We evaluate it from 1 to t, and this becomes the limit as t goes to infinity. And when we plug in t for x, we get negative 1 over t, and then minus a minus, plugging in 1 for x, which is plus 1. And now let t go to infinity. This equals to 1 minus the limit t goes to infinity of 1 over t. That limit is 0, and therefore we get 1 minus 0, which is 1. And we make the conclusion that the improper integral, so the integral from 1 to infinity of 1 over x squared dx, converges to 1. The area below the graph of 1 over x squared, above the x-axis, to the right of 1, is equal to 1 squared unit. So we can draw that picture. And here is the graph y equals 1 over x squared on the side in the first quadrant. And there's x equals 1. And we shade all that area in there. We now know that that area is equal to 1 squared unit. There is another way to evaluate this integral, slightly different. So I'm including it here. If you prefer the second way, then you should use that. So here we'll not be taking the limit initially. We'll be taking the antiderivative initially. The antiderivative of 1 over x squared is negative 1 over x. We evaluate it from 1 to infinity. That infinity up there means we take the limit as x goes to infinity of negative 1 over x, and then we're subtracting a negative 1, which means we're adding 1, and of course we get the same answer. So either way is perfectly fine as long as you do it correctly. And again, we conclude that the improper integral from 1 to infinity of 1 over x squared dx converges to 1.